Welcome to Dr. Physics Coder YouTube channel. Today we will learn about fundamental concept of quantum mechanics. You can listen us during sleeping. I can promise you can sleep faster. Let's start by asking, what is quantum mechanics? Well, it's a fundamental theory in physics that provides a description of the physical properties of nature at the scale of atoms and subatomic particles. It's the foundation of all modern physics, explaining the behavior of matter and its interactions with energy on the scale of atoms and subatomic particles. By contrast, classical physics only explains the behavior of matter and energy on a scale familiar to human experience, including the behavior of astronomical bodies like the moon. Quantum mechanics is important because it provides a theoretical basis to modern physics and chemistry. It explains the nature of matter and energy at the molecular, atomic, nuclear, and even smaller levels. It's thanks to quantum mechanics that we can understand how these particles behave as they create the world around us. Quantum mechanics also gives us revolutionary concepts like superposition, where particles can exist in multiple states at once, and quantum entanglement, where particles become interconnected, and the state of one can instantly affect the other, no matter the distance. It's a field that's as fascinating as it is bizarre. But why should we care? Well, without the principles of quantum mechanics, we wouldn't have many of the technologies we take for granted today. Everything from the computer you're using to watch this video to the GPS that helps you navigate relies on understanding the quantum world. So, quantum mechanics is not just about esoteric theories and complex mathematics. It's a crucial part of our everyday lives, shaping the way we interact with the world around us. It's a theory that's still evolving, with scientists around the globe working tirelessly to uncover its mysteries. So, prepare to have your mind stretched as we venture into the quantum world. Imagine, if you will, being in two places at once. Sounds impossible, right? Not in the quantum world? Here we're introduced to an intriguing concept, the particle-wave duality. This principle forms one of the cornerstones of quantum mechanics, defying the classical physics norms we've come to accept. The particle-wave duality suggests that all particles, from the tiny electrons to the photons of light, can exhibit properties of both particles and waves. Quite a mind-bender, isn't it? It's like saying a tennis ball can also behave like a wave in the ocean. To understand this, let's delve into a famous experiment, the double-slit experiment. When scientists fired particles like electrons or photons one at a time through two slits onto a screen, they expected to see two bright spots, each corresponding to one slit. But contrary to expectations, they observed an interference pattern, characteristic of waves. This meant that each particle didn't just pass through one slit, but interfered with itself, like a wave to pass through both and form a pattern on the screen. Crazy, right? But what if we try to catch these particles in the act, peeking to see which slit they pass through? Well, the universe doesn't like to be outsmarted. When observed, the particles act like proper particles again, passing through one slit and leaving just two bright spots on the screen. The wave pattern disappears, as if the particles knew they were being watched. This strange behavior suggests that particles can exist in multiple states or places at once, like a wave, until they are observed. Upon observation, they collapse into a single state or position, like a particle. This highlights the essence of particle-wave duality. Particles can behave both as particles and waves, depending on whether they are observed or not. So, in the quantum realm, it seems that particles can dance between being solid matter and elusive waves. This duality is a fundamental aspect of the quantum world, one that continues to baffle and fascinate us, pushing the boundaries of our understanding of reality. Now, what if I told you that a quantum particle can be in multiple states at the same time? This might sound like a line from a science fiction movie, but it's actually a fundamental principle of quantum mechanics known as superposition. You see, in the quantum world, things don't behave as they do in our everyday reality. A quantum particle, like an electron or a photon, doesn't have a definite state until it's measured. Instead, it exists in a kind of fog of potential states, all at the same time. This is the essence of superposition. Imagine you're flipping a coin. In the everyday world, the coin is either heads or tails, but in the quantum world, it's as if the coin is both heads and tails at the same time until you look at it. It's only when you observe the coin that it chooses to be either heads or tails. This might seem strange, but it's a reality that's been proven time and again in the laboratory. To illustrate this concept, physicist Erwin Schrödinger came up with a thought experiment involving a cat. Imagine a cat in a box with a radioactive atom that could decay at any moment. If the atom decays, it triggers a mechanism that releases a deadly poison, killing the cat. But until we open the box and look, we don't know whether the atom has decayed or not. So according to quantum mechanics, the cat is both alive and dead at the same time. It's only when we open the box and observe the cat that it becomes either alive or dead. This is the strange and wonderful world of quantum superposition. It challenges our everyday intuition and opens up a realm of possibilities that are truly mind-boggling. So, until a quantum system is observed, it exists in all possible states simultaneously. Quite a mind-bender, isn't it? Now let's get entangled in the strangest phenomenon of quantum mechanics. Quantum entanglement is a unique phenomenon that has baffled scientists and philosophers alike. Imagine two particles connected in such a way that the state of one instantly influences the state of the other, no matter how far apart they are. Sounds like something from a science fiction movie, right? Well, welcome to the world of quantum mechanics. This intricate dance of particles is a result of a process known as entanglement. When particles are entangled, they become interconnected, forming a unified system. An action performed on one particle instantly affects the other, even if they're separated by vast distances. This seemingly magical link persists, irrespective of the space between them, defying our conventional understanding of space and time. In the realm of quantum mechanics, the entangled particles are not considered as individual entities, but as a single entity. They are so intimately linked that they must be described with reference to each other. It's as if they have a secret line of communication, a hidden bond that allows them to instantly know the state of their partner particle. But what does this mean for us? Well, the implications are profound and the potential applications are mind-boggling. Quantum entanglement could revolutionize communication, enabling instant transmission of information across vast distances, creating unhackable networks. In the field of quantum computing, entanglement could lead to computers that perform calculations at speeds unimaginable today. Yet, quantum entanglement is not without its mysteries. It challenges our understanding of the world, pushing the boundaries of what we thought was possible. Albert Einstein himself referred to it as spooky action at a distance. Despite its perplexing nature, or perhaps because of it, quantum entanglement continues to captivate scientists and laypeople alike. Quantum entanglement, defying our conventional understanding of space and time, truly showcases the enigmatic beauty of quantum mechanics. So, how does this all fit into our lives and the world around us? Well, the quantum world may seem distant and abstract, but it's much closer to our daily lives than we might think. The principles of quantum mechanics are shaping our technological future, and the effects are already starting to show. Let's take a look at quantum computing. Traditional computers process information in binary form, using bits that can be either 0 or 1. But a quantum computer uses quantum bits, or qubits, which can be both 0 and 1 at the same time, thanks to a principle called superposition. This allows quantum computers to process massive amounts of data at speeds that are currently unimaginable. Quantum computing could revolutionize fields such as artificial intelligence, drug discovery, climate modeling, and even financial modeling. Then there's quantum cryptography. Our online security today largely depends on the difficulty of factoring large prime numbers, a task that would take traditional computers years to accomplish. But a quantum computer could do it in a blink. This might sound like a hacker's dream, but there's a flip side. Quantum cryptography can create security systems that are virtually unbreakable, ensuring our online communications remain secure in the quantum age. And it doesn't stop there. The principles of quantum mechanics could lead to advancements in many other fields, from quantum sensors that could detect disease at a much earlier stage, to quantum materials that could supercharge our electronic devices. We're only scratching the surface of what's possible. The quantum leap into the future is happening right now, and it's a journey that promises to be as thrilling as it is unpredictable. Quantum mechanics, although perplexing, paves the way to a future full of unimaginable possibilities. So keep questioning, keep discovering, and remember, the universe is under no obligation to make sense to us.